So I didn't get a chance to talk too much about inequalities, so I wanted to take a second and just talk a little bit about inequalities and solving rational inequalities. So we actually can solve these algebraically, but I prefer actually if you solve them by graphing. So I've gone ahead, here's our inequality. I went ahead and showed you how it would go into the calculator. This is a 6 right here, my cursor's there. Notice that I put parentheses around the whole denominator. So this is the 6 over x minus 8, and then I wanted to compare it to 3, so I put a 3 in the y2. So you can see the graph over here. Here's the 3. So here's where we're comparing to. No surprise, we've got an asymptote here at x equals 8, right? So we know that x can't be 8 from over here, so that's that asymptote. And then we have this y equals 3. So the question is, when is the rational? So let me change colors here. So when is this graph here, this piece of it and this piece of it? Ooh, I missed that, huh? Right? When are those two pieces less than or equal to 3? Okay, so it looks like in two places it's less than 3. Looks like we've got this area right here, and then we've got all this area over here, right? So less than 3. So I've got this red line at 3. When is the output less than that? So it's less than it right over sitting over here, and then it's also less than it over here. So this part over here is pretty easy to find. So we can find that without any problem. So we have our asymptote at 8, so that means x has to be less than 8. Right? And it can't equal 8 because at 8 we end up having an asymptote. So that's all these x values right here. So this is x is less than 8. That's giving us all those y values that are less than 3. And then to find this other piece over here, we're going to have to find where the graph intersects. Okay, so I thought I was being all on top of this, and I took this graph out because I was working on the next one. So let me put this in really quickly again. So x minus 8, and we're still comparing to 3. So here's the graph. I have the window a little bit bigger here, but there's the graph. Okay, so I'm looking for this intersection right here. So I'm going to go to second calc. I'm going to go to the intersection. Okay, I'm going to move my cursor so that it's closer over there. Okay, so remember, it doesn't have to be right on there. That was super lucky that I got that. It doesn't matter, just as long as it's close. I'm going to enter to the other line. I'm going to enter again for a guess. And so that intersection right there is at x equals 10. So right here where they're intersecting, x equals 10. So the other piece of my answer here is or x is greater than or equal to now 10. Because when x is 10, y is going to be exactly 3. Okay, notice I put an or here. There's definitely a disjunction. This is in two pieces. See how many colors I can get over here, right? I've got this piece over here and this piece over here. They're going in opposite directions, so definitely a disjunction there. Okay, so I've got one more. You can see that I had it. Probably going to have to go back to it again. So in this one I have 9 over x plus 10, and this time I want to look at is greater than 3. So here's the graph. I again adjusted the window already because we have an asymptote here at x equals negative 10, and we're not surprised because over here we know that x can't be 10. And then I compared to 3. Okay, not all of them are going to be compared to 3, just the two I picked were compared to 3. So this is y equals 3. So the question is, when is this thing, I missed it again, when is this thing greater than 3? So it looks like there's just one place here where it's greater than 3. I'm going to take it right here. So this is greater than 3 all the way till I get right there. So that's the only place where the graph of the 9 over x plus 10 is greater than 3. So I can see that it's going to bump up to the asymptote. So I've got x is greater than negative 10. That's kind of this way over, right? And it can't equal negative 10 because there's an asymptote there. And then right when I get to this place, So notice if I kind of draw in another vertical line there, it's greater just in between there. That's where we're going to be greater than 3. Okay, do you see the overlap there? I'm going to use an and. You could also put your x in the middle. And then let me find this intersection really quick. So let me change this real quick. Okay, so I'm looking for this intersection right here. And I'm just going to move the cursor so it's fairly close there. And it looks like I get x equals -7. So I'm talking about right in between here and our vertical asymptote. This is the only place where we have this greater than, and so here's our answer. Which again, if you want to write an inequality this way, you can as well. So x has to be less than -7 and greater than -10. And notice I did less than -7 because this one is just less than. In the previous one it was an or equal to. So solving inequalities, rational inequalities, is all about just using the graph. If you want to talk about the algebra sometime, I'd be happy to talk to you about that. But just some thoughts on solving with your graph.